It is represented as IE, ionization energy. So in the periodic table, this is a subtopic, ionization energy. I will give the definition and the factors affecting ionization energy. Then we will discuss ionization energy of D block elements. What is definition of ionization energy? Ionization energy definition: amount of energy, required, required to remove an electron from outermost orbit. Outermost orbit of an isolated neutral gaseous atom. Isolated neutral gaseous atom is called as ionization energy. Ionization energy. Let us see the factors affecting ionization energy. What are factors which affect ionization energy? According to periodic table. See, in the periodic table also we'll discuss like this only. Again, I am revising. Okay. Factors affecting ionization energy. Atomic radius. Atomic radius. Second one, important factor, electronic configuration. Electronic configuration. Effective nuclear charge. Effective nuclear charge. Screening effect or shielding effect. Screening effect. Screening effect. Or also called as shielding effect. Okay, let us revise atomic radius. How atomic radius affects ionization energy. Electronic configuration, effective nuclear charge, screening effect or shielding effect. We are discussing periodic table actually now. Revision of periodic table before entering into ionization energy of D block elements. Okay. Anybody can you tell me how radius affects ionization energy? Online students? Effect of radius. If size or radius of element is more, its ionization energy is inversely proportional to size. If size of the atom is more, ionization energy is less. Okay, right. Next, electronic configuration. Electronic configuration. You tell me how electronic configuration affects ionization energy. Online students, how electronic configuration affects ionization energy. Elements with tell me completely half filled or completely fully filled should have high ionization energy. Completely half filled or completely fully filled. Completely fully filled. Possess high ionization energy values. High ionization energy values. This is very useful in the D block elements. Okay. Next, effective nuclear charge. Effective nuclear charge. See, if effective nuclear charge is more, then ionization energy is more. Effective nuclear charge. Effective nuclear charge means attraction power of the nucleus on the outermost electron or electrons present in the orbit. IE is directly proportional to effective nuclear charge. Effective nuclear charge means net attraction force of nucleus on the outermost electron. Effective nuclear charge. This effective nuclear charge increases while we move from left to right in the periodic table. Okay, while we move from left to right in the periodic table, effective nuclear charge increases and ionization energy also increases. That's why right side elements possess high ionization energies. Next, screening effect. Screening effect or shielding effect. Screening effect are also called as shielding effect. What is screening effect? Okay. See, take an atom A and B. Okay. Imagine one extra orbit is present in the atom B. Means in between outermost orbit and the nucleus, one orbit is present. Okay. And in A, there is no orbit in the middle between outermost orbit and the nucleus. Let us put some electrons here. Okay. Between nucleus and these two electrons, attraction forces are more. Effective nuclear charge is more. Effective nuclear charge is more. So it is difficult to remove the electron from atom A, because electrons are strongly attracted by nucleus. But in case of B, in case of B, one extra orbit is present in between nucleus and outermost orbit. See, these pink color electrons are present in between outermost electrons and nucleus. They act like a screen. Due to inner orbit electrons, nuclear attraction power do not spread up to outermost orbit. See, attraction forces are not acting on the outermost orbit and outermost electrons. So how to define screening effect or shielding effect? The decrease in the nuclear force of attraction on the outermost electrons due to presence of inner orbit electrons. The decrease in the nuclear force of attraction on the outermost electrons or outermost orbit due to presence of inner orbit electrons is called as screening effect. Okay. See, here screening effect is more or less. Tell me. Screening effect. Screening effect is more. Screening effect is more. In the middle, screen is present. Just imagine that pink color electrons act like a screen. Screen is present. So screening effect is present. Consider these four electrons as a screen. Screen is present. Screening effect is present. Right here, there is no screen. There is no inner orbit electrons. There is no screen. There is no screening effect. Now, in which case, means from which atom we can remove electrons easily? B, from B, because in atom B, this electron is free from the nucleus, right? Attraction forces are not acting, so you can remove easily. You can remove easily. If I write energy required to remove electron as IE1 here, and if I write IE2, what is the relation here? Tell me. What is the order? IE2 is greater than IE1. IE2 is greater than IE1. So how can we give the relation? There is no screening effect here. No screening effect. No screening effect. No screening effect. You tell me. If screening effect is more, then ionization energy is less. So inverse relation. Ionization energy is inversely proportional to screening effect. So I revised the periodic table concept also. Okay. Now coming to the D block elements ionization energy value. Same factors, everything is same. Okay. Right. But in D block elements, we use electronic configuration concept mostly. Online students, are you getting? Online students. Let us take D block elements. D block elements and their ions. Fe plus 2 and Fe plus 3, which is having more ionization energy. First of all, write electronic configuration of Fe plus 2. Electronic configuration of Fe plus 2. Fe plus 2, Fe plus 3, ionization energy values. Online students, please respond. What is Fe plus 2 configuration? First of all, write iron configuration. Argon 4s2 3d 3d6 iron. See, first we should remove electrons from the s orbital. Remember, don't remove electrons from the p orbital. First remove electrons from the s orbital. Remove two electrons, Fe plus 2, argon 4s0 3d6 d6. Fe plus 3. How many electrons we have to remove? We have to remove 3 electrons. Right? Fe plus 3 configuration, argon 4s0 3d5, 4s0 3d5, which is having stable configuration. Online students, Fe plus 3 or Fe plus 2? Fe plus 3, stable, d5 configuration, d5, completely half filled. See, this is completely half filled configuration, stable configuration. So it is difficult to remove electron from the Fe plus 3 ion than Fe plus 2. So ionization energy of Fe plus 3 is more than Fe plus 2. Ionization energy of Fe plus 3 is more than ionization energy of Fe plus 2. Okay. This is easy, right? Can you do one question? Compare ionization energies of these two. Next example. Please respond, online students. Mn plus 2 and Cr plus 3. Compare IE1 for ionization energy relations. Samra, can you answer? Samra, am I audible to you? Ketura, can you? Kirti, Ketura's answer is Mn plus. What about others? Others also. Please respond, other students. See, Mn plus 2 configuration. First of all, write manganese configuration. Manganese configuration is argon 4s2 3d5. Okay. So remove two electrons from s orbital. Argon 4s0 3d5 d5 configuration. Chromium plus, first of all, write chromium configuration 4s1 4s1 3d5. This is chromium. Chromium plus means 4s0 3d5. Both are having stable configurations. Both are having same ionization energies in this case. Okay, if we consider ionization energy for manganese as IE1, for this IE2. Then relation is IE1 is equal to IE2. Both are having same ionization energy. Okay, this is a common question. Common question. Writing electronic configurations and comparing ionization energy values. And again, we are going to periodic table. Means ionization energy is application of periodic table only. Now, indirectly, we are discussing periodic table concept only. Okay, right. Next model question. All of you look at this example. Before taking example of D block elements, let us take alkali metal, or alkaline earth metal. Better to take alkali metal, sodium. Sodium. What is sodium atomic number? 11. Sodium electronic configuration 1s2, 2s2, 2p6, and 3s1. 3s1. See, in periodic table, we learn like this. If we have three successive ionization energies, for example, IE1, IE2, IE3, then relation between them is like this. IE1 is less than IE2 is less than IE3, and so on. What is the meaning for this? All of you look at this. I'm taking an atom with the three electrons in it. Okay. These three electrons are tightly attracted by nucleus, first electron, second electron, and third electron. Let us consider amount of energy required to remove first electron as IE1, second electron as IE2, third electron as IE3. Means you can remove first electron easily. Removal of second electron is difficult. Removal of third electron is highly difficult. Fourth electron is highly difficult, right? Okay. If we give some values like this 100, 200, 300, what is the increase? Tell me. 100. What is the increase? See, of course, IE2 is greater than IE1, IE3 is greater than IE2, no doubt. But see, the increase is what is that considerable? Okay, not that much high. Okay, 100 increase here also 100 increase, right? But overall, IE1 is less than IE2 is less than IE3. Clear? Okay. Once look at this. We took sodium. We took sodium. Online students, are you getting? Hello? Keep. IE1. IE1. The amount of energy required to remove first electron. So we are removing first electron, 1s2, 2s2, 2p6, IE1. See, minus electron, one electron is removed. One electron is removed. Right? Online students, are you following? Hello? No one is responding. See, if you give the values, IE1 will be some 100. Then IE2, guess IE2. What may be IE2 according to previous comparison? 200. IE2. See this. IE1 is 100, IE2 is 200. So I have to write 200 in general, right? But what is this value? How that abrupt sudden increase is taking place? Why? See, after removing one electron from the sodium, it is getting inert gas configuration. This is configuration of neon configuration. Neon is inert gas. In the entire periodic table, inert gases are having high ionization energy values. Clear? That's why sudden jump in the second ionization energy takes place. How questions will come and came previously also. See, which of the following element is having third sudden jump in the ionization energy? Which of the following element is having sudden jump in the second ionization energy? Like that. See, I'll tell you one trick. After removing first electron, if we get a stable configuration, then we can observe sudden jump in the second ionization energy. After removing one electron, if we get a stable configuration, then there is a sudden jump in the second ionization energy. Similarly, you tell me, after removing two electrons, if we get stable configuration, then we can observe sudden jump in third ionization energy. After removing one electron, if we get stable, we can see second is sudden jump. After removing two electrons, if we get a stable configuration, then we can see third sudden jump. Remember this. Increase one. After removing one electron, see here, this is only the example. After removing one electron, we got a stable configuration. So there is a sudden jump in the second ionization energy. Increase one. For example, if you remove three electrons, if you get a stable configuration, then you can observe which sudden jump in which ionization energy? Fourth. Increase one. Clear? We apply same logic in the T block elements also. T block elements also. Online students, did you get this? Online students. Online students. No one is responding. What happened? Which of the following element has sudden jump in third ionization energy? Sudden jump in third ionization energy. Juji? Zubair, can you try? Zubair? Zubair? First of all, write chromium. Chromium. Chromium configuration argon. Argon 4s1 3d5. 4s1 3d5. Remove first electron, ionization energy 1. Ionization energy 1. Tell me. Argon 4s0 3d5. 3d5. After removing, we are getting stable configuration. 3d5 is stable. So it's a second ionization energy, sudden jump. Sudden jump. But the question is third ionization energy. So this is not correct. Chromium is not correct. In chromium, we are observing sudden jump in the second ionization energy. Let us take manganese. Sorry. Argon 4s2 3d5. Ionization energy 1. Remove first electron, then we'll get argon 4s1 3d5. Remove another electron, ionization energy 2. Argon 4s0 3d5. See, here one electron is removed. Here one electron is removed. We remove two electrons. After removing two electrons, we got a stable configuration. So its third ionization energy is very, very high. So sudden jump in the third ionization energy takes place. In order to remove third electron, we should apply more energy because it is stable configuration. So answer is manganese. Manganese. Can you say for vanadium? For nickel is okay, leave it nickel. Can you try for vanadium? All of you try for vanadium? You only tell me. Which, in which high ionization energy sudden jump will take place for vanadium? Right, vanadium configuration? First ionization. Any idea? Online students for vanadium. Vanadium configuration is argon 4s2 3d3. After removing 5 electrons, it will get a stable configuration. Sixth, sudden jump takes place. It will get argon configuration no? After removing 5 electrons. Sudden jump. We'll take inertial gas element as the criteria. Okay. Right. Next, general characteristic properties of T black elements. I already given some properties yesterday. Again, I will revise. Okay. Inertial gas, yeah. Inertial gas only we consider. Yeah. Generally, for alkali and alkaline earth metals, we take the neon. We take neon configuration. For this, we take argon. Okay. So, characteristic property. Characteristic properties of D block elements. Most of the D block elements are reactive metals. Yeah, they have high melting and boiling point values. High melting point and the boiling point values. Form complex compounds. They act as catalysts. Act as catalysts. They form alloys. Form interstitial compounds. Interstitial compounds. So magnetic property and color property. So magnetic and the color property. Coming to first one, complex compounds. Why D black elements form complex compounds? What are the reasons? First one, formation of complex compounds. Online students, tell me why D block elements form complex compounds. Online students, why D block elements form complex compounds? Due to first point, small size. Second one, effective nuclear charge. Effective nuclear charge. Third one, availability of vacant d orbital. Reasons are very, very important. Availability of vacant d orbital. Second one, as a catalyst. D black element as catalyst. What is the reason for their catalytic property? Why D black elements act as catalyst? Due to their ability to form variable oxidation state. D black elements act as catalysts due to due to their ability due to their ability to exhibit variable oxidation states. Variable oxidation states. Some examples. Element or compound and process. Platinum. Platinum is used in making sulfuric acid, making H2SO4. V2O5, vanadium pentoxide. It is used to convert SO2 to SO3. To convert SO2 to SO2 to SO3 in the manufacture of sulfuric acid in contact process. In contact process. In making sulfuric acid, H2SO4. Third one, nickel. Nickel is used in making saturated compounds from unsaturated or in the hydrogenation of oils. In hydrogenation of oils. MnO2. MnO2. In the decomposition of KClO3. In decomposition of KClO3. Potassium chlorate. KClO3. Iron. Iron. In the manufacture of ammonia in Haber's process. In manufacture of ammonia. In which process? In Haber's process. Ziegler-Natta catalyst. Ziegler-Natta catalyst. What is the composition of Ziegler-Natta catalyst? CaCl4 plus trimethyl or triethyl, any alkyl group. Trimethyl or triethyl aluminum plus titanium tetrachloride called as Ziegler-Natta, used in the polymerization. Polymerization of what? Alkenes. Polymerization of alkenes. Wilkinson's catalyst. Wilkinson's catalyst. Triphenyl phosphine, rhodium chloride. Tell me composition. Triphenyl phosphine, rhodium chloride, commonly called as it is used in homogeneous catalysis. Homogeneous catalysis. Triphenyl phosphine, rhodium chloride. Online students, are you following? Hello. And interstitial compounds. Explain that one in last. Interstitial. What is the definition of interstitial compound? Yeah. Interstitial compound. D block elements form interstitial compounds. Interstitial compounds. Interstitial compounds are the compounds which are formed by trapping of small atoms like hydrogen, boron, carbon, nitrogen in the lattice sites of d block metals. Okay. Compounds formed by trapping of smaller atoms, smaller elements, hydrogen, boron, carbon, nitrogen in lattice sites or interstitial sites. Lattice sites, the best word is interstitial site. Means gaps only. Interstitial site means gap. Between atom to atom, gaps are present. Interstitial sites of crystal lattice. Crystal lattice is the name for a metal, another name like synonym, crystal lattice. Look at this order. This is a D block element. D block element or metal. Imagine these are the gaps. These are gaps. If these gaps are occupied by smaller atoms like the formed compound is called as interstitial compound. Hydrogen. These gaps are occupied by smaller atoms. This is called interstitial compound. What are the properties of interstitial compounds? Write the properties of interstitial compounds. High melting point. High melting point. Than parent metal. Than parent metal. These are inert. Means less reactive than parent metal. Inert. These are tough compared to parent metals. These are having similar chemical property as that of parent metal. Different physical property. Similar chemical properties but different physical properties. Okay. Correct. Next. Color property. What is the condition for color property? Condition for color property. Condition, not reason. Condition. Presence of at least one unpaired electron in the metal atom, neutral atom or its ion. Presence of single electron. Presence of single electron or unpaired electron is the condition. Why D black elements exhibit color? Reason. Online students, due to DD transition. What is DD transition? See, D orbitals are classified into two types. T2Z, T2Z and EZ. T2Z and EZ. Electrons make transition between T2Z and EZ. Due to these transitions, D black elements and their compound show colors. This transition is called as DD transition because this is D orbital, this is also D orbital. T2G means a type of D orbital. D orbital, D orbital. Okay, condition for color properties, presence of single electron and reason is DD transition. But exceptional cases, what are the exceptional cases? What are exceptional cases? For example, look at this all of you. Will Fe plus 2 show color property? Fe plus 2. What is the configuration of Fe plus 2? Argon, 4s0, 3d6, d6. In d orbital, how many electrons are present? 1, 2, 3, 4, 5, 6. How many single electrons are present? 4 single electrons are present. So, Fe plus 2 exhibit color. 4 single electrons are present. Okay. What about chromium 6 and Mn plus 7? Chromium 6. Configuration of chromium 6. Argon 4s0, 3d0. Chromium 6. Okay. 6 electrons we have to remove. Is there any electron in the d orbital? No. Its configuration, Mn plus 2 configuration. Argon 4s0, 3d0. You know what is chromium configuration? Chromium configuration argon 4s1, 3d5. We have 6 means we have to remove 6 electrons. 1 here and 5 here. All electrons are removed. Manganese configuration argon 4s2, 3d5. We have to remove 7 electrons. 2 here and 5 here. So total electrons were removed. Clear? So is there any electron in the d orbital? No. Then how? Means are they colorless? No, they are colored. But how? Because condition is presence of single electron due to charge transfer spectra. Yes. Actually, this should be colorless, but these are colored ions due to charge transfer spectra. Two cases are there. See, Mn plus 7 means it's ion MnO4 minus. Okay. Cr2O7 minus. Colored ion. This is also colored ion. Colored ion. Okay. Online students. Let us write the colors of some compounds. Okay. Zn plus 2. In Zn plus 2, is there any single electron? All are paired only. Once look at this. Zinc configuration is argon 4s2 3d10. 4s2 3d10. Zn plus 2 means argon 4s0 3d10. D10. All are paired. All are paired. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All are paired only. There is no single electron. So Zn plus 2 is colorless. Copper plus colorless. Is there any single electron? No. Manganese plus 3. Cr plus 3. Vanadium plus 2. Violet color. Common violet. Violet. Try to remember colors. If situation is bad, then colors also will come. Okay. Green color. Vanadium plus 3. Nickel plus 2. Green color. How to remember this color? Vanadium plus 3, vanadium plus 2. Online students, are you listening? Online students? Hello. See, I'll give my code. You also prepare your code, okay? First, take violet. I think you may not like, but I'll give. If you wanted to prepare the code. But I'll give you. Man carried yellow crocodile in van. See, if you read 10 times, this is very easy. Okay. Man stands for MN plus. Okay. Violet color, sorry. Violet. Color is violet, no? Instead of writing, I will violet color. Crocodile. Color is violet, okay. In crocodile, chromium plus. Van stands for. Remember, in our course, start vanadium with plus 2. Increase plus 2, next vanadium plus 3, next plus 2. Okay. Now you tell what is the code? Violet crocodile in van. You know van? College van, school van. Sorry. Just one trial, okay? This is better rather than that because highly dry. Remembering code is very difficult. Hmm. Say one girl name, Rui. Hmm. Yes, correct. Vani. Vani. Vani has iron deficiency. So eat green vegetable. Online students, hello, online students. Are you there? Online students. I won't take online class then. Hmm. Ketra, tell me elements in Vani. What is the condition for vanadium? First, it should start with a plus 2. Next, plus 3. Vanadium plus 3. Nickel plus 2. Nickel plus 2. Nickel, because common oxidation state for nickel is plus 2. Nickel plus 2. Hmm. Iron deficiency. Iron also start with a plus 2. Plus 2 only. Starting numbers. Green. Student Vani has iron deficiency due to more hard work without eating anything for night. Next code. Next code. We are discovering one new cream. If we apply that cream to our skull, then we will remember all the formulas, everything. That cream name is discovered by Pratya Academy student. What is that cream name? Code 3. Code. What is cream name? V cream. CREM. V cream. Blue color. V cream stored in copper vessel. Right. What is the color? Blue color. Cream is in blue color. That is stored in which vessel? Copper vessel. Now you tell me. Yes. V stands for vanadium plus 2 is used. Vanadium Plus 3 also used. Vanadium. Vanadium plus 4. Vanadium plus 4. Here Cr stands for, in the cream, can you see Cr? Cr. Cr plus 4, already plus 3 used there, no? Plus 4. Plus 4. Next copper. Copper plus 2. Copper common is plus 2. Very important, copper salts or copper salts are blue in color. So blue color. So write next. Online students, hello. Are you following girls? Hello girls. Ketra, tell me three elements, three ions and their colors. Ketra, based on last code, tell me Ketra. Ketra. Copper means plus 1 or plus 5 or plus 6. How can I know? Huh? Copper plus 2. Copper plus 2. Next. Vanadium plus 4. Next. Okay. Color is blue color. So these are enough. We have codes, right? Practice them and it is very easy to use. Okay. Next. D block elements form Li. Li forming ability. Next heading. And what about paramagnetic property? Just a second. Paramagnetic, diamagnetic. Just a second. Paramagnetic property. Paramagnetic property. What is the condition for paramagnetic property? Condition. Presence of single electron or unpaired electron. Single or unpaired electron in d orbital. What is the value for magnetic moment? Mu is equal to root over n into n plus 2. Units are Bohr magnet. That is the right one. Example. Fe plus 3. Fe plus 3. How many electrons it is having? Argon 4s0, 3d5. All are singular only, na? 1, 2, 3, 4, 5. 5 single electrons. N represent number of single electrons. Here n is there, no? That n represent number of single electrons. Substitute n value. Root over 5 into 5 plus 2. How much? Root 35 means root 36 value 6. So can 5.8 Bohr magnet. Okay. Second example. Zn plus 2. What is its magnetic moment? What is the configuration? Argon 4s0, 3d10. We have to remove 2 electrons. Actually 4s2, 3d10, not remove 2 electrons from the d10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All are paired only. Is there any single electron? No. N is equal to 0. Substitute n value in that formula 0. So 0 Bohr magnet. Okay, right. Next, Li forming ability. Li forming ability. What are Li? Li. Li is a mixed metal. Li is a mixed metal. You know steel glass, steel plates. That is just example for Li. Brass, bronze. NTA is giving questions based on the applications. Okay, how we use the metals in our day-to-day life. In JMS is scheme, that's why more chance to get in NEET also. So remember important alloys and their composition, very very important. Online students, online students. alloy, and composition. Brass. Any idea? Copper plus zinc. Bronze. Copper plus tin. UK silver coin. Copper plus nickel. UK silver coin. Copper plus nickel. Stainless steel. Say one code, Santosh. Ne? Sacronic. Like gibronic. Protonic. Sacronic. Discover one new code. Iron, chromium, nickel, carbon. Important. Stainless steel composition. Because we use stainless steel in our day-to-day life. Glass, plates, glasses. German silver. German silver. In German silver, what is present? Silver is common because silver is used. In German silver is not present. Copper plus zinc plus nickel. German silver. Silver is not present in the German silver. Bell metal.